Okay, so start off, we're going to skip through on your yellow packet. Okay, on the yellow packet, we're going to skip through sections A through C for a while. Okay, those are not priority clusters. So you actually start it like that. So target, oh no, you were right. Target A is on the front. Skip all the way up to target D. And this is number 3 through target D. And then you just kind of follow along from there. Okay, so we're going to go through these. We'll be able to talk about a lot of these without spending a whole lot of time. So I want to show you some tricks, and I want to talk about the algebra both. Right? Talk about ways we can beat the test, but then also review the algebra, so so you're ready for that too. So choose the expression that's equivalent to this expression. We're just going to look at all these and see which one's equivalent. Now notice this where it says choose the expression that's equivalent. It's only looking for one answer, right? So this is really truly like a multiple choice question. So what could you do? What are our options on this?
Guess and check.
I mean, no, let's not guess and check on this one. There are some of them where it kind of is a little bit. I mean, there in some cases that might be all right, but not on this one. What are we going to do? If we're going to do the algebra, what would we do? What could I do to this expression up here to make it simpler? I could simplify it, right? I could just follow order of operations, regular order of operations, top down, simplify operations. Let's put all phones and stuff away, please. Everything away. I got undivided attention up here. This is my way of helping you do well on this test, which is going to be an important test for you. So I want you with me. All right, so what could we do? Well, we could simplify this by just, what can I do? There's nothing I can do inside parentheses, so that one's checked off. Exponents, yeah, there's a 2, so I could multiply this out, right? I could multiply that out and then multiply that out and then combine like terms. That's one thing I could do. Real quick, when we're doing something like x plus 5 quantity squared. Okay, how do I multiply that out? Is that equal to x squared plus 5 squared? No, it is not. It's not equal to x squared plus 5 squared. It's equal to, when I square something, it means I'm multiplying it by itself, right? So it's equal to x plus 5 times x plus 5. Now there is a pattern that we use for that, which I'm going to review right now real quick, and then we'll use it again on other problems. Do you remember what the shortcut is for this? A plus b squared. There's an expansion pattern for that.
Squared
Plus
2ab.
2ab, very good. 2ab plus
B squared.
b squared. Very good. So that makes it quicker, right? So that allows us to get the answer pretty quickly. If I do x plus 5 quantity squared, then that's just going to give us, what's that going to give us? Well, a squared is going to be x squared. 2ab, 2 times x times 5 is 10x, good. So plus 10x. And then b is 5, b squared is 25. The other thing I could do, if I forget that, it's not that big a deal, then I would just take the x and distribute the x, and then I would take the 5 and distribute the 5 to the other. From the first polynomial, I'll distribute everything to the second one and add up like terms. And if I do that, I'm just going to get that answer, right? So then what am I going to get here? So this gives me x squared plus 10x plus 25. And then if I multiply all this out, what am I going to get? So if I distribute the x to the x and the x to the 1, what's that give me? So just this part right here is going to give me what? X times x is x squared. X times negative 1 is negative x. Now I'll distribute the 5. 5 times x is 5x, and then I'll distribute the 5 to the 1. What's that? Minus 5, you're right, minus 5. And then what would those terms combine to if I add those like terms up? 4x. So that's what all this stuff is equal to. But notice I'm subtracting the whole product, so it's got to go in parentheses, right? So I'm subtracting x squared plus 4x, right? you told me that negative x plus 5x is 4x minus 5. And then I would just distribute the minus sign and collect like terms. So what would that give me then? That's going to give me for my answer x squared minus x squared. It's going to cancel, isn't it? Right? 10x minus 4x is what?
6x.
Okay, and then 25 minus negative 5
30.
is 30, because I'm adding, right? Subtracting a negative is adding. So I'm going to get 6x plus 30. Well, one thing I could do is I could just go down here and do that to all of those and see which of them work, or which one works. Well, that's not going to work, is it? Pretty clearly, x minus x is going to give, the x is canceled there, so that one's off the table. If I distribute the 4, I'm going to get 4x plus 20. That's different, right? What about this one at the bottom? If I multiply, you can think about it this way, if I multiply this x all the way through, aren't I going to get an x squared in there? Everybody agree? You with me on that? And then to multiply by 2, I'm going to get, for this one, I'm going to get 2x squared plus some stuff. Well, there's no x squared in that, right? See what I'm saying? So that one can't be it either. So just by the process of elimination, we know it's C. I could do this one though, right? If I just work inside the brackets, x minus x, those cancel, right? And then I've got 5 minus negative 11 is positive 6, right? So all that stuff in there just becomes a 6. So I get x plus 5 times 6. All this stuff just became a 6. So when I distribute it, I get 6x plus 30.
That's a 1.
What's that? Where are you looking? Right here? That's, I was just crossing it out. Those cancel.
Minus 1.
Right? Okay.
No,
Oh.
it's minus 1.
Oh,
Yeah.
okay, minus 1. Same, it's 5 minus negative 1. I said 11, didn't I?
Yeah.
5 minus negative 11, or minus negative 1, did it again, is 6, right? So it still is 6. I just said the wrong thing, right?
Yeah.
Okay, that's a lot of work. That you could do it that way, though. That's the math way of doing it. I wanted to go through at least one of those the whole way through doing all the algebra. But is there maybe a better way to do this? The good news is, yes, there is. There's an easier way. I want to show you some really good tricks.
Just okay, educate.
No, not that. You could do, okay, one thing you could do is you could say, you might recognize that I've got a common factor here of x plus 5 that I could undistribute from those two terms, which would leave me with an x plus 5 to the 1 minus an x minus 1. Maybe you see that, but here's the great trick. All you'd have to do to check these, and listen to this really carefully, because this is one, I got a ton of mileage out of this. In my life, taking all these standardized tests, I've done this a million times, and it works. It's so easy. All you got to do, if I'm trying to choose equivalent expressions, those are expressions that are equal to each other, right? Just in different forms. All I have to do is pick a random value of x and plug it into the top one and see which one of those gives me the same value when I plug in that value of x. You get it? So let's pick something like 2. Okay? And you could use a calculator for this, and they're going to give you a calculator on most of these. But if we pick a value like, let's just say, arbitrarily, let's just randomly say x equals 2. Okay? Don't pick something like, we'll talk more about this. So let's pick 2. What's the top one going to give me if I let x equal 2? So that becomes a 2 plus 5 squared, 2 plus 5, and 2 minus 1. Well, what's 2 plus 5?
7.
7 squared is, so this is equal to 49 minus, 2 plus 5 is,
7.
2 minus 1 is, so 7 times 1 is 7. 49 minus 7 is what? 42, okay? So all we got to do then is just try all these and see which one is going to give me back 42. Isn't that an awesome trick? So easy. So if we plug in 2 here, 2 plus 5 is 7, 2 minus 1 is 1, 7 minus 1 is not 42, right? 2 plus 5 is 7 times 4 is 28. That's not 42. 2 plus 5 is 7 times, what do we get here? 7 minus 1 So what is that? 7 times 7 minus 1. What's 7 minus 1? 6. 7 times 6 is 42. What do you know?
Wow. Thanks, man.
Okay, so that's it. Now, it's possible, when you're doing this though, it's possible that you're gonna get the same value accidentally down here too. What if I did? I'm not going to, right? If I plug in 2, I'm gonna get 7 times 1 times 2 is 14. But what if, let's just say what if that had turned out to be 42? What could I do to break the tie between those two? Pick a different number. Pick 1 or something, right? See what I'm saying? Pick easy numbers, right?
Well, so if they both equal 42, then you narrowed it down to those two, though, right?
Then I would have narrowed it down to those 2, and then I could say, okay, well, it might just be that those 2 functions happen to cross at that value, x value. It's possible. I mean, it could work that way. So if it did, I would just put in, let's just pick 1 and see which, when I put 1 up here, see which one of these has the same value when I pick a different x value, right? Because if it's the right answer, it's going to work for every x value, not just accidentally for 1. You get it?
Yeah.
Okay. Okay, what about this? So this is determine whether each expression is equivalent to the expression 27x cubed minus 729. Mark yes or no for each expression. So the math way of doing this would be, we've done stuff like this, right? Would be to maybe factor this thing and see what we get when we factor it. Okay, and we could. Right, we could write this as, remember that whenever we're trying to break apart an expression, we've got a polynomial there with 2 terms. If we want to break that apart and factor it like these are, remember our strategy for 2 terms is using a pattern. And these are our only patterns, right? We've only actually got 3 of them because a sum of squares, sum of squares doesn't work, right? So that one we can just cross off. We've only got a difference of squares and a sum or a difference of cubes, and that's it. So which one would this be?
Difference of cubes.
Difference of cubes. And remember how we can remember this one as, if I have a cubed minus b cubed, whatever the sign is right here, when we write out this expression, it's going to be the same opposite plus when we're doing the difference or sum of cubes ones, right? Same thing up here. If that's a plus, we'd get the same opposite plus, so sop, right? And then we just know that a cubed minus b cubed, we're going to get a small factor and a big factor. Remember talking about this? In the first one, we're going to get an a and a b. In the second one, those are our 2 terms. In the second one, we're going to get an a squared, an a times b, and a b squared, right? Okay, and so we could factor this, and if we did, what does this look like? If I take 27 x cubed minus 729, could I write that as a difference of cubes? Something cubed minus something cubed? 729 is what cubed?
729.
No, what cubed is 729? What number could I cube?
14.
No, 9. It's 9.
Oh.
Okay. So 9 cubed is 729. You're going to have a calculator on these though. So you could, what would be the easy way to take a cube root? And the calculator actually is just this calculator. So you got to kind of get used to using this one. Oh, not that one. Sorry. It's that one. Where'd it go? Oh, it's right here. Okay, so
Whoa.
how could I easily take the cube root of 729? I think there may be a cube root button down here, but I don't see it. Other functions.
There was on the brackets test.
Yeah,
Oh, here it is right here. Here's an nth root. So we can do a cube root if we want to of cube root of 729, right? And that gives me 9, okay? Or if I want to, I could also just do, instead of a cube root, what would that exponent be? 729 to what power if it's a cube root? To what? 1/3, yeah. So I could do 729, and then I just hit the caret to get up to the exponent to the 1/3, and it's 9. Okay, either way. All right, so I could, thanks. She's not here.
Oh, she's not.
No, not here.
Thank you.
So So that's one thing I could do, right? I could think of this as being 9 cubed, and then 27x cubed is what quantity cubed? 3x, right? Because I have to be able to distribute that 3 to the number to get 27 and the variable to get x cubed, right? And then I would just follow that pattern, no big deal, right? This is a cubed, and that's b cubed, and so I would just follow this pattern right here, no big deal, right? But could I trick the test here?
Yeah.
What would I do?
What about you, Brett?
Put a value in for x, right? Put a value in for x. So we could do, in fact, I've already kind of done, I'll show you another tricky way to do this. So if we were to,
Can you just put in all the equations and see what it comes?
well, you could. That's the other thing you could do, is you could just graph these things and see which ones are the same equations, right? So if I graph, here's the first one, right? Now, I'm going to show you, this is kind of a cool way of doing this, though. If I'm going to put these equations in, pay really close attention to this, because this is another thing, you can get a lot of mileage out of this. So the original function up here, let's call that f of x, okay? So f of x is 27x cubed minus 729, so it's graphed on there. We're not even going to necessarily have to use the graph on this, though. Let's take each of these functions, and I'm going to graph those, but I'm going to call them, or I'm going to put them into the calculator, but I'm going to call them a of x, b of x, c of x, and d of x, right? This is what's cool about this Desmos calculator. If I've defined f of x to be 27x cubed minus 729, this makes it really easy for me to plug in a random value. Let's just pick a random value, like, how about 11 is the one I picked earlier, right? If we just pick a random value like 11, and I'm going to plug that into those functions, how could I ask the calculator what the value of this function is when x is 11? How do we say that? If f of x is 27x cubed minus 729, Brandon, how am I going to say plug in 11 for x? So, but I mean, if I want to know, so like what we did before is we just picked a random value of x and plugged it in to see what this function equaled, right? How do we do that? If f of x is 27x cubed minus 729, what if I want x to be 11?
Put 11.
F of 11, exactly. I could just go down here and put f of 11. See what I'm saying? And it knows that this is the pattern for f. It's that function. So if I plug 11 in, it's going to put 11 in for x and give me an answer, right? You see that? So if I plug 11 in for x, I got 35,208. If I plug 11 in for a, I got 35,208, right? What are the odds that's going to be the same? Not very good, right? So those are the same, aren't they? If I go down for C, which was this guy right here, when I put 11 in, I got something different, right? So that one is not an answer. Oh, B was different too, wasn't it? Sorry. A was the same. That was this one. B was different. It gave me back a different value. So did C, but D gave me back the same value as F, right? So do you see then that A and D, those were the two that were the same? You get that? Right? So all you got to do is just write in, if I want to plug in values of X, instead of just putting in 27 times 11 cubed, write it in terms of X, write it as a function, and then just plug in whatever value you want for X. Got it? Okay, that's good. That's helpful. All right, so keep going here. Okay, what about something like this? Okay, so this is just another example of where they want you to simplify this, right? So let's take, this is something that I don't think we've really done this year. You would have done stuff like this, though. Hopefully you would have done stuff like this in Algebra 1. If you haven't, we'll just review one of these. It'll make sense to you. But what if we wanted to do, we want to simplify something like 6 over x plus 5 over x plus 4. What's our rule? When we add fractions, what do we always have to get? Like, we have to get a common denominator, right? So if I wanted to add something like 2/3 plus 1/4, what would my common denominator be? It'd be 12. Yeah, how would I get it? I mean, why'd you say 12?
4 and 2.
4 and 3 both go into that, right? In fact, the easiest way to get a common denominator, and it doesn't have to be the smallest one necessarily, the easiest way to get one would be to say, well, whatever's on the denominator is there, let's multiply this one by top and bottom by that, right? And whatever the denominator was over here, multiply the other fraction top and bottom by that one, right? Same thing up here. My common denominator is just going to be x times x plus 4, right? So we'll multiply the first one by the quantity x plus 4 over the quantity x plus 4, right? And we'll multiply the second one by x over x. See what I'm saying? So then what's that give me? On the bottom, I have my common denominator of x times x plus 4, right? See that? What about up here? I'm going to get 6 times x plus 4 plus 5 times x. So that's all they're asking you to do is fill that stuff in, right? We're just getting a common denominator. Okay? No big deal. You get as much time as you want, I believe, on this test. So take all the time you need. I don't have any problem with you. I don't care if you're gone for a few days. We can just put things on hold. I want you to take your time and do a good job. What about this? This is pretty simple, right? All we're doing here is just simplifying. They want us to take this expression up here and turn it into a simple polynomial. So what would we do? How would I take this product of 3 times 3x plus 2 and 2x plus 4 and simplify it? So what would I do? Yeah, just distribute. Yeah, I'm just going to multiply out, aren't I? Now, you could do this in any order you want to. I would recommend, if you're going to do this, why don't we take the second 2 before we distribute the 3 and multiply those out and simplify and then distribute the 3 through. So we don't have to have such big numbers. Either way is going to work, though. It's not going to matter in terms of your final answer. Maybe just a little simpler. So if we distribute, then let's go with the 3x, distribute that through, what's that going to give me? 3x times 2x is 6x squared. 3x times 4, 12x. Now let's distribute the 2. 2 times 2x is, those are like terms, right? And then 2 times 4. So that gives us 3 times what? 6x squared plus 16x plus 8. And if I distribute the 3 all the way through, what do we get? 18x squared, good. Plus 3 times 16 is 48x, plus 3 times 8 is, so we were just filling in those blanks, right? That's all we wanted, was that and that, right? Okay, make sense? Okay. Okay, same thing, right? I'm not even going to bother with this. This would just be the same thing, wouldn't it? We would just be multiplying this out, adding like terms, and then whatever the coefficient of t is, that's what they want, right? Just want you to write this in simplified form, and you're just filling in the blank to write it in simplified form. Okay? Could you legally cheat on this? Yeah, you could. You could, right? We could say, what if t equals, I mean, we could try, well, actually, you could just try all those in there, couldn't you? And see in which case is this side going to give you the same as that side when I let t equal 2 or something, right? Okay, so you could use that same trick. What about down here? Okay, I would say, how could you kind of finesse your way through this here? If I were going to multiply this top one out, if I were going to multiply this whole thing out, would you agree I'm going to get x squared plus a bunch of other junk? Everybody see that? If I FOIL it out, and that's really all we need to know. I'm going to get something times, I'm going to get something times when I distribute the x squared plus a bunch of other garbage, right? What about down here? If I multiply this one out, I'm gonna, x plus 2 squared, isn't that gonna give me x squared plus a bunch of other stuff? Everybody agree? Right? So this is gonna give me down here 4 times x squared plus a bunch of other stuff. So what goes in the box? 4 has to, right? How could I kind of just trick the question? Well, we could just, once again, we could try all these and see which one is gonna work when I pick a certain value for x, because they have to be the same thing, right? So pick x equal 2 and see which of these is gonna make the top one the same as the bottom one, right? Okay, let's see. Okay, this is a real quick one. So 3 equivalent equations are shown here. So Ariel, what are we gonna do with this? If we want, these are all the same, they're equivalent equations for f of x, different ways of writing it. We want to circle the form that reveals the zeros of f of x, right? It's gonna reveal the zeros, gosh, keep doing that. It's gonna reveal the zeros of f of x without changing the form of the equation. So which one of those gives us the zeros of the function? Think what the zeros are. The zeros are where the function equals 0, right? So in each case, I would just be setting the equation equal to 0. Which one's going to give me the zeros? Yeah, the first one, because it's factored, right? We just set the factors equal to 0. So what are they? 5 and 9. That's what we, right? So part A, we'd circle the first equation. Part B, we're just going to circle what the solutions are, right? And we've done a ton of that stuff. So that's right in our wheelhouse. We're good with that. So what about this stuff too? We're good with this, right? We've done a lot of properties of exponent stuff. So if I divide like bases, what do? This is not going to be given to you on the test. I'm just putting this up here to remind you. Right? So if we, quotient of powers, if we divide like bases, we subtract, right? So that's just going to be x to the 12 minus 4, x to the 8th. Right? And that's all they wanted you to write it in that form, x to some power. Okay, good. What about this? If we want to write this in the form x to the n to the m. Well, remember, if we take a power to a power, right? If I take a power to a power, x to the n to the m is really just equal to x to the n times m, right? If we take a power to a power, we multiply the exponents. So all I've got to do is pick values of n and m that multiply to what? 18. So there's a bunch of different answers you could pick. Any of those would be fine. Okay. Let's see. And then this same thing here, right? All we're going to do is we're just going to simplify this expression. So if we've got something like the quantity b to the negative 4, c to the negative 2, b to the 5th cubed, well, let's just simplify. So can I do anything inside the parentheses? Can I combine? Do I have any like bases that are being multiplied? The b's, yeah. So b to the negative 4 times b to the 5 is b to the what? No. If we multiply like bases, we just add the exponents, right? So it's just b. Yeah, it's b to the 1, isn't it? So this is going to equal b to the 1. I don't even have to write the 1. C to the negative 2 times 3. And then what do I do if I'm going to take each of these to a power? If I take a power to a power, what do I do to the exponents? Multiply. So I'm just going to distribute the 3 to both of the exponents. So I'm just going to get b cubed c to the minus 6. Okay? No biggie. You got this. Same kind of thing here. I won't even do that one. Same kind of thing, right? 10 times negative 5 is negative 2. X cubed times x to the 1 is x to the 3 plus 1, x to the 4. Y squared times y to the 4th is y to the 2 plus 4, y to the 6. Okay, you got it? Okay, this one, I'm just going to do, for you guys, I'm just going to remind you about, we did some stuff like this, but let's just look at a calculator approach to this. Okay, what if we were to pull up our Desmos calculator, and let's get rid of all these. Okay, so what if we want to put this into the form ax minus h squared plus k, right? One thing we could do is just graph the function, right? Because think about what those tell us. A tells us whether it's been reflected or stretched vertically, right? H and K just tell us the vertex. So what if we just graph this thing and we get all that information right from the graph, okay? So we could do x squared, let's do y equals, or f of x equals, either one's going to work, x squared minus 10x plus 36. Okay, on this graph, look what this allows us to do. This allows us to, we can just drag this thing around. I can find the vertex. The vertex is at 5, 11. So what are the values of h and k? 5 and 11, right? Those are the values of h and k. Now, normally with a parabola, we would go over 1 and up 1, right? Everybody agree?
Yeah.
Okay, because 1 squared is 1. So has this been stretched at all? It has not, has it? Hasn't been stretched. And so a is equal to 1. So a is 1, h is 5, k is 11. So that's all we have to do is plug that stuff in. Plug in a 1 for a. We don't write it then, right? H is 5, k is 11. Right? No big deal. Okay, we could complete the square to get that, but there's an easier way. Okay, we'll skip that. Okay, what about this? Which equations revealed the minimum or maximum value for f of x? Okay, we could graph these, but these are all going to be parabolas, aren't they? Right? Everybody agree that these are all, that's got an x squared in it, that's got an x squared in it, that's going to give you an x times an x is going to give you an x squared, right? But these ones right here are written in a form that makes sense. They're written in the form a times f of x minus h plus k, right? What's the parent function? So the parent function here is just a plain old parabola, g of x equals x squared, right? So what is this one saying then? This one is saying f of x equals a times x minus h squared plus k. So what's the value? I could look at this and say, what's the value of a? 1. What's the value of h? What's the value of k? So we know what this one looks like then. This one, that one right there would just look like the parabola with a vertex at 3, 2, and a is positive, so it opens up, right? So we could see there pretty easily what the minimum or maximum value would be, minimum in this case, right? See what I'm saying? Because it's in that form. It's in the form a times the quantity x minus h squared plus k. So is that one. What's a? What's h? What's k? -7. So we don't even need to graph it. We just see that we could if we wanted to. Both of those would be easy to graph and find the minimum or the maximum. Find the vertex, right? Make sense? Okay? All right, last one. Do one more. Piece of cake, right? All we'd have to do on this one, this is nothing. We're just supposed to write an expression equivalent to that by combining like terms. Just combine like terms. Just distribute the negative sign here and add up like terms. Right, so we'd add up all the x squareds. We'd add up all the xy's. We'd add up all the constants, and that's it. Right? Okay, no big deal. We got it. Okay. Wow, we'll cut it off there.